We have seen Laplace transforms properties. So can we just take a quick recap? What is the first property?
Linearity.
Linearity. Correct. Second one?
Change of scale.
Correct. Change of scale. Next, third one?
First shift.
First shift.
First shift. Correct. Then?
Multiply by t.
Right. Multiplication by t. Next was?
Division by t.
Right. Division by t. Correct. And sixth was, after division, we have seen Laplace transform of derivative of function. Right.
Derivative.
Correct. Correct. D by dt of the f of t or f dash of t. So do you just remember, this is very straightforward. What is change of scale? Laplace of f of a t is, if Laplace of f of t is f of s, then Laplace of f of a t is 1 upon a f of s upon a. You have to remember, please. What is first shift? Laplace of,
E raised to at.
correct, e raised to at into f of t. So what is that? F
F
of
of s minus a.
s minus. Correct. Then multiplication by t, t raised to n, if it is multiplied to f of t, then what is it? Minus 1 raised to n, nth derivative of the function.
Of the f of s.
Right. Then division by t, Laplace of f of t by t is integration of the function with respect to s. Multiplication by t is derivative and division by t is integration, and limits of integration are
Yes to infinity.
Integration.
s to infinity. Correct. Right. Next, Laplace transform of derivative. So what is that Laplace of f dash of t? How do we define it? Yes, into f of s minus f of 0. Do you remember? Or you can also write it as s into Laplace of f of t minus f of 0. So what is in general Laplace? Sorry,
Screen is not visible.
check now.
Yes, madam.
Okay. So Laplace of nth derivative of t, it is s raised to n f of s minus n minus 1 f of 0, n minus 2 f dash of 0, so on minus up to last term is fn minus 1 at 0. Right? This is what we have seen up to the last lecture. These many properties. So the last property remain in this session is property number 7, right? Laplace transform of integral. Now derivative we have seen lastly. First change of scale, first shift, then multiplication by t, division by t, Laplace transform of derivative, and last is Laplace transform of integration. So yes, we'll define it now. If Laplace of f of t is f of s, then Laplace of integration of this f of t. And once you write integration, you should write it with respect to t. But here you will remember the limits should be 0 to t for this property. Integration limits are from 0 to t. Okay. So if we are integrating on this side from 0 to t, on the other hand side, you should divide by s to your function f of s. Are you getting the property? If you are integrating from 0 to t, on left hand side, on the other hand side you should divide by s to your function f of s. Or it can be also integration from 0 to t, and inside the integration you can change the variables because Laplace depends on t and s. What the Laplace does is it changes the domain t to s. So yes, it should be in t only. But inside integration, it's up to you. You can change the variables. So if it is u also, it is okay. Is there any other variable? That is also okay. Okay. So if you change that t by u, it can be like this: integration from 0 to t f of u du. It's just the variable. So what will be? It will be same 1 upon s into f of s. That is what is integration. But here you are supposed to remember that the limits of integrations are 0 to t for this property. Okay, so can we go to the question? And if there are double integration, then here it is s square, triple integration, s cube, and so on. Write the question. Find the Laplace transform. Integration 0 to t sine 2u du. Okay, but I told you Laplace always have t in it as variable, but here it is u. If it is inside integration, you can change the variable, but initially it should be in t, right? So what is this function and what is the property on that? Come on, what you will first consider and what is the property? Can you just consider sine 2t? On that, you have to take the integration of that sine 2t with respect to t from 0 to t. That is the property, integration from 0 to t of f of t dt. And you can just change the variable t by u. So you will first consider Laplace of sine 2t. While considering, initially you should consider t always. Don't consider it as u. Okay. What is this?
2 upon a square plus 4.
Correct. This is Laplace of sine 2t. Then on that sine 2t, what you want is integration by property. You are not actually going to find the integration, right? You just apply integration on this side from 0 to t, left hand side. Integration from 0 to t on that sine 2t, and once integration is there, dt always there. Okay, so if you take integration from 0 to t on this side, what will be the change on other side?
Divide by s.
Correct. So if you are taking the integration on this side, the opposite side is divided by s. So whatever is this, it should be divided by s. So it is 1 by s into your answer, 2 upon s square plus 4. But they asked you u, right? So that t can be changed by u inside integration. It is possible. So yes, you are changing t by u, but if you are changing t by u also, limits remains the same, 0 to t. Okay, that is 1 by s, 2 upon s square plus 4 as your final answer. It is very easy, just divide by s. If you are taking the integration, just divide by s on other hand side. Done. Is there any doubt? Please ask. No doubts? Consider the next question then. Find Laplace transform of integration from 0 to t into cos hyperbolic at dt. How will you solve this? Can you tell me the steps? What you'll first consider and which are the property?
consider Laplace of cos hyperbolic 80.
Correct.
Then apply multiplication by t property.
Correct.
Then integration.
And then integration from 0 to t, integral property. Correct. So you are first considering here Laplace of cos hyperbolic 80. What is that?
Yes upon
Yes
square
upon s
minus
square minus s.
Very. S upon s square minus a square. Right. On that, you should apply t next. So t into, and one more thing. Integration, wherever it is, you should apply it there itself. You cannot exchange here. It is not possible. Okay? So e, t, we have exchange, but integral is wherever it is, you have to apply it there itself. And derivative also. You cannot change the place of, you cannot change the place of derivative integrals. Okay, so you have to apply now t. T is multiplication by t is on other hand side. Minus
Minus
1 t by
d by
ds
ds of yes.
of this. Very good. To take the derivative of this, there are two functions, numerator, denominator. So that is u by v rule. What is that? Minus sign as it is. V into derivative of u. What is derivative?
Minus
1 minus u into derivative of v. That is
2s.
2s upon v square. S square minus a square brackets. So if you solve this, s square minus 2s square, that is minus s square minus a square. There is negative sign out. Minus s square minus a square upon denominator. Right, so if you multiply inside by that negative, it is s square plus a square upon s square minus a square bracket square. As Laplace transform of t cos hyperbolic 80. Now on this, what we need is
integral
integration from 0 to t. This dt comes with this integration, remember. So now, next property is integration. So Laplace of integration 0 to t of this t cos hyperbolic 80 with respect to t is, what will be the answer?
1 upon
1
s
upon
into
s.
s
Correct.
square.
Very good. So whatever the answer comes of this t cos hyperbolic 80, to this answer itself we are multiplying by 1 by s, or that is dividing by s. S square plus a square, s square minus a square, bracket square, done. That is your answer. Is there any doubt? Please ask. No doubts? Chal, good. Can we go to next question then? Find Laplace transform of, write the question. Integration from 0 to t e raised to u into u cube du. How will you solve? What you will consider first and then what?
T cube.
Correct. Will you consider u cube or t cube?
T cube.
T cube.
T. Correct. You will consider t. So Laplace of t cube. What is that? T raised to n. N is a positive integer. So it is n factorial upon s raised to n plus 1. That is 6 upon s raised to 4. Corrected?
Yes, ma'am.
Right. On this, you should multiply by what? E
T
raised to
t.
t into t cube. And this property is partial.
Partial.
So what do we do here? We replace s
Yes
by
by
s minus 1. Correct. So e raised to t into t cube is done. On that, you should take the integration from 0 to t. And if you take the integration, you can just change the variable t by u. So e raised to u into u cube du is. What will be the answer? On this, we have taken integration from 0 to t. So other hand side, 1 by
1 upon
s. Done. Answer. Finish. So now here's after you will see the functions on that all the properties which we have seen like first shift, multiplication by t, division by t, derivative, integration, all such things you will solve together. Can you just try this next question? Find Laplace transform of integration 0 to t u inverse e raised to minus u into sine u du. Just think and tell me how to solve. What are the steps? And u is actually t. So wherever is u, you can actually call it as t first. And finally, while taking integration, you can change it by u. So yes, tell me now, what did you first consider?
Laplace of
Sine t.
sine t.
Correct. On that,
T raised to minus 1.
t raised to minus 1. What is the
1 upon
property? That
1
is
upon t.
correct, division by t. And then e raised to minus t, which is first shift, right? So these two are exchangeable, but wherever is integral, that is not. So integration is last at the end. So yes, first means actually we are going like this, no? So this is last. So yes, its place is here itself, so we are not changing it. So yes, we are considering first sine t. What is that?
1 upon a square plus 1.
Correct. 1 upon a square plus. On that, you can apply this or this, your choice. So you will apply this now. T inverse sine t. But T inverse, I'll make it clear. 1 upon t sine t. That is division by t. Okay, so division by t, what will be on other hand side?
Integration.
Integration. Correct. From s to infinity, right? Right. So what is that? Laplace of t inverse sine t integral. What is that integration?
Tan inverse.
Tan inverse s.
Tan.
Correct. Tan inverse s. From s to infinity. It is tan inverse infinity minus lower limit is s itself. So tan inverse s. What is tan inverse infinity?
Pi by 2.
Pi by 2 minus tan inverse s. And what is pi by 2 minus tan inverse?
Cot
Cot
inverse.
inverse s. Right. So we got here t inverse of sine t, Laplace of t inverse sine t. On that, we need, on this t inverse sine t, you will need e raised to minus t. So apply the next property, multiply by e raised to minus t. On the left hand side, t inverse sine t. So if you multiply by e, that is the first shift. So in this, s will be replaced by,
S plus 1.
S plus
right, as this is minus 1, so s is s plus 1. Cot inverse s plus 1. And on this, finally, you will take the integration from 0 to t. E raised to minus t, t inverse sine t dt. And what is that then? Integration
1 upon S.
1 upon s. Very good. You just divide by s on other hand side. That is the answer. Or the way they asked you, integration 0 to t. T they called u,
U.
right? So u inverse e raised to minus u, these two are exchangeable, into sine u du is 1 upon s cot inverse s plus 1. Done. So are you getting every property now? How to apply?
Yes, ma'am.
Good. If there is multiplication by t, there is division by t, derivative, integral, never take actual integral. Apply the property and write the answer. That's it. Next question. Find Laplace transform of integration 0 to t 1 minus e raised to minus u upon u du. Think for some time and tell me what you are going to do. How will you solve?
Consider Laplace of 1 minus e minus u. Then apply derivative property and then
Integral. Very good. But instead you should consider t. So you are considering Laplace of this 1 minus e raised to minus t. Can you separate?
yes,
Yes, ma'am.
By linearity. Very good. So minus Laplace e raised to minus t. So what is that?
1 upon yes,
1 upon s. Minus 1 upon
yes plus 1.
s plus 1. Correct. On this, you should divide by t first. So yes, divide by t. 1 minus e raised to minus t upon t. Division by t is
Integration.
integration.
Integration
From
yes to infinity.
s to infinity of s. 1 upon s minus 1 upon s plus 1 ds. Whenever integral comes with respect to ds that comes. Okay. So this two can separate. Integration 1 upon s is
Log yes.
log s.
Log.
Very good. Minus what is this?
Log yes plus 1.
Right. Is its derivative above function and the derivative?
Yes.
Right. So s derivative is 1. And in such cases, it is log of denominator. The integration is log of denominator. So log of s plus 1. And this is from s to infinity. But this is log a minus log b. That is log a upon.
Yes upon yes.
Right. S upon s plus 1 from s to infinity. And in such case, if we put infinity here inside log for both the s, then what will be the value?
0.
0.
Very good. So 0 minus s is s itself. So log s upon s plus 1. It is minus of log s upon s plus 1, or if you don't want negative, you just exchange numerator denominator. So it is s plus 1 upon s. This is what? But Laplace of 1 minus e raised to minus t upon t. Yes. On this, what do we need is integral. Right. Take the integration from 0 to t. On this. So here you can change the variable t by u upon u du. Just I'm writing t as u. And what will be the answer?
1 upon yes log of yes plus 1 upon yes.
Very good. Whatever is this, you just divide it by s if you are taking the integration. Done. The answer. Is it clear now to everyone? Is there any doubt? Next question is for you. Please solve. Find Laplace transform of 1 upon t integration 0 to t u cube du. Come on, steps. What is first, then what, and then what?
TQ first.
Correct. Laplace of t cube first. What is that?
6 upon s raised to 4.
Right. So 6 upon s raised to 4. Very good. On that, can you exchange these two?
No.
No. Wherever is integral or derivative, you cannot exchange. So integration is there at the number 2. On this, it should be there itself. 0 to t on this, so you can change the variable t by u cube du. On this, what you can do?
1 upon s.
1 upon s. Very good. On this, so it is like 6 upon s raised to 5. And now on this, you want division by t. So yes, I'll divide by t to this. And what will be the other hand side? Division by t is what?
Integration 0 to s infinity.
The integration from s to infinity, correct. So yes, we have to integrate. So here 6 is constant outside integration. You can take it up s raised to minus 5, it will be. And what is the integration? X raised to n dx formula.
Into x raised to n plus 1.
X raised to n plus 1 upon n plus 1. This is the integration, and derivative is n into x raised to n minus 1. Please remember integration. So yes, it is like that. S raised to n ds, just the variable is s here. So it is s6 into s raised to n plus 1 minus 5 plus 1 minus 4 upon minus 5 plus 1, that is minus 4, from s to infinity. So minus 4 will come out, 6 upon minus 4 into s raised to minus 4 from s to infinity. That is minus 3 by 2. 1 upon s raised to 4. It can come down from s to infinity. So minus 3 by 2. If we put the infinity here, 1 by infinity raised to 4 is infinity. Minus lower limit is s itself. And what is 1 by infinity?
0.
0. Minus 1 upon this is as it is. So minus minus here becomes plus. So 3 by 2, 1 upon s raised to 4. Is the required answer? Yes.
Yes.
So it is Laplace of done. So is there any doubt in any of the property? You can ask now, because here your Laplace ends, Laplace transform with all its properties. Half part of the unit is over. Laplace is over. Now the next part will be inverse Laplace transform. Means like whatever we did in derivative and exactly opposite we did in integration. So the same thing which we do in Laplace, exactly opposite thing we'll do it in inverse Laplace. Okay, so half part is there, but Laplace, whatever we have seen in Laplace, exactly opposite we'll do it in inverse Laplace. Means once if it is clear with Laplace, you can easily do it in inverse Laplace. One more question comes for you. Please solve this. Find Laplace of integration 0 to t u e raised to minus 2u sine 3u du. Try this. So you will consider what first?
Laplace of sine 3t.
Correct. Laplace of sine 3t. 3 upon s square plus 9. 3 square is 9. On that, you can either do this or this, your choice. So you will multiply by t first on this. Multiplication by t is
Minus 1 d by ds of p of p.
correct. 3 upon s square plus 9. So minus 3, derivative of 1 upon something. What is the derivative? 1 upon something minus 1 upon something square into derivative of that something, that is 2s. Or what you can do is you can take it up with inverse and something raised to n also you can use there. Now this is minus minus plus 3 into 2 6s upon s square plus 9 bracket square t sine 3t. You all are solving with me, please? Yes. T into this is done. On that you should write next is e raised to minus 2. What do you write?
T.
T. Correct. Into t sine 3t. Which property is this? Name of this property? First shift. And what will be the change?
Yes is yes plus 2.
Very good. Wherever is s, it is now s plus 2. With all the attributes remain same. Yes. So on this next you should integrate from 0 to t. So I'll do it here. Laplace of integration 0 to t. And inside the integration, you can change the variable by u. So e raised to minus 2u, u, sine 3u, d. Yes, on this we have taken integral. So what will be the other hand side?
1 upon s f
1
of s.
upon s, correct. On this you should divide by s. So all things are as it is. And there is only 1 upon s to that. That is the final answer. And if you want, finally, you can replace if you want. No need to do, but yes, done. Is there any doubt? Okay, we'll take one last question on Laplace and then we'll go to the inverse Laplace. Find Laplace transform of instead wait. You will take one evaluate type. Evaluate integration from 0 to infinity e raised to minus t into integration 0 to t sine u upon u du dt. How is the question? First thing, evaluate. You have to find the value of this particular value. So such questions you will solve by what?
Comparing with
Correct.
integration 0 to infinity.
Correct. Comparing with the definition of Laplace transform. That is integration 0 to infinity e raised to minus st f of t dt. So what is s? If we
1.
compare, right, s is 1. And what is f of t?
Integration 0 to t sine u upon u.
Sine u upon u du. Right? Then you have to find Laplace of this, and on that you will put s is 1 and you will get the required answer. So to solve this Laplace, you will first consider what?
Laplace of sine t.
Right, Laplace of sine t, that is
1 upon u square plus 1.
right. On that sine t, your next,
Division by t property.
right, dividing by t, that is division by t, and on the other hand, it is integration s to infinity of this. So what is that integration?
Tan inverse yes.
Right, tan inverse s from s to infinity. That is tan inverse infinity minus tan inverse s. What is tan inverse infinity?
Pi
Pi by 2 minus tan inverse s. Or it can be cot
2.
inverse s. Done. Sin t upon t done. On that you are writing integration from 0 to t property. And you can now change the variable t by u, sin u by u, du. Yes. So what is that?
1 upon S cot inverse.
Right, 1 upon S to the answer, cot inverse S. Right, so we got the Laplace of this which we needed, and into that finally the required answer will be, put S is 1.
Yes.
So we'll get the required answer 1 by 1 cot inverse 1. What is cot inverse 1?
Pi by 4.
Oh, good, good. You have to find this. Can you see this in calculator? Can we find it? Is there cot inverse? Can you check? आहे
Sin cos आणि tan एवढंच आहे.
त्याच्यावरती शिफ्ट मध्ये आहे का?
No ma'am, sin inverse
No,
cos
ma'am.
inverse tan.
Okay, then you should remember such values. Tan pi by 2 is infinity. So tan inverse infinity is pi by 2. Tan pi by 4 is 1. And cot pi by 4 is also 1 upon tan, right? So it is also 1. Please remember. Done. The answer is pi by 4. If you don't know this cot inverse, you can write it here itself. Tan inverse 1.
1.
Tan inverse 1. Pi by 2 minus tan inverse 1. And you can solve. Tan inverse 1 is also pi by 4. Pi by 2 minus pi by 4 is again pi by 4. You can check. So yes, here it ends the Laplace transforms. We'll start with inverse Laplace transform. Okay, so we know the Laplace transform of f of t is f of s. Then Laplace inverse, notation. It is L, and on it above is inverse, so L inverse of f of s is f of t. काय केलंय? दोन्ही बाजूला लॅपलास इन्व्हर्स अप्लाय केलाय. सो लॅपलास इन्व्हर्स ऑफ लॅपलास ऑफ एफ ऑफ टी is Laplace inverse of f of s, and inverse and Laplace get cancelled, so here it is just f of t is equal to Laplace inverse of f of s. And what the Laplace inverse does, it transforms domain s back to domain t. लॅपलास मध्ये टी एस मध्ये जात होता, आता इन्व्हर्स मध्ये एस टी मध्ये जाईल. Understood the definition and the notation? Laplace is L and Laplace inverse is L inverse of what? But f of s. There should be s now. Now we should obtain some definitions. आपल्याला काही definition Laplace मधल्या माहिती आहेत, त्या तुम्ही मला सांगायच्यात. Accordingly, we'll convert them in inverse Laplace. Okay, so the first definition in Laplace was, say, Laplace of 1. What was that?
1 upon s.
1 upon s. So in inverse Laplace, the first definition becomes taking Laplace inverse on both sides. So Laplace inverse of 1 upon s is 1. Is that correct?
Yes ma'am.
Okay. म्हणजे आता तुम्हाला इथनं आतापर्यंत दिसत होतं की लॅपलास ऑफ 1 तिथं आपण 1 by s लिहायचो. आता तुम्हाला जर असं काही दिसलं लॅपलास इन्व्हर्स 1 by s की त्याला तुम्हाला 1 लिहायचं. म्हणजे आता आपण एक्झॅक्टली अपोजिट जाणार आहोत. Next definition in Laplace was Laplace of e raised to at. What was that?
1 upon s minus
So can you define the second formula in inverse Laplace?
Laplace inverse of 1 upon s minus a is equal to e raised to at.
Correct. Laplace inverse of this is this. Third, Laplace of e raised to minus at. That was 1 upon s plus a. So third definition here becomes Laplace inverse 1 upon s plus a is e raised to minus at. Next definition. What was the in Laplace transform? I think it was c raised to at, right?
Yes.
You can ignore this in inverse Laplace because 1 upon s minus a log c something is never asked in inverse. So we are ignoring that formula. Next, after that, we'll take Laplace of sine at. What was that?
A upon s square plus a square.
Correct. A upon s square plus a square. So here the formula is 1 upon s square plus a square. We cannot take a there as constant. So if it is 1 upon s square plus a square, what will be?
1 upon a sine 80.
Very good. If a is here, then it is sine 80. But if a is not there, that a should be divided. Or it is division by a on both sides so that a is removed. Or you can simply divide by a. So it is 1 upon a sine 80. You have to remember now them. Inverse Laplace formula. Okay, next in that was Laplace of cos.
80.
S upon s square plus a square. Constants are okay that there is 1, 1, 1, but if it is a s term, you cannot ignore. So s upon s square plus a square. म्हणजे वरती जर 1 असेल किंवा कॉन्स्टंट असेल तर ते साइन किंवा साइन हायपरबोलिकला जाईल आणि यस असेल तर कुठे जाईल ते
Cos or
राइट नो नो अपॉन प्लस आहे सो इट इज cos 80 राइट करेक्ट नेक्स्ट फॉर्मूला Laplace of sine hyperbolic 80 what was that
A
a
upon
upon
a square minus a square.
right so here it will be Laplace inverse 1 upon s square minus a square that is
1 upon a sine hyperbolic.
sine hyperbolic 80 very good 1 upon this that a should be divided to this side if you are taking Laplace inverse here and Laplace inverse so they get cancelled we have seen 7 next formula cos hyperbolic 80 what was that
80.
Yes upon
Yes
a
upon
square
yes.
minus a square.
right so here it is Laplace inverse s upon s square minus s तुम्ही सोडू शकत नाहीये s असतील ते घ्यावंच लागेल हा so it is cos hyperbolic 80 correct right so next one more formula we'll need here are these 7 clear are the 7 formulae clear to everyone
Hyperbolic 80.
sin hyperbolic cos yes beta
Yes, ma'am.
yes good so now last formula remained in Laplace is Laplace of
No,
T
ma'am.
raised
t raised to n what was that
T raised to
n
n
factorial.
factorial upon s.
n factorial upon s raised to n plus 1 if n is positive integer and it is gamma n plus 1 upon s raised to n plus 1 in general. Now we are interested in this formula Laplace inverse 1 upon s raised to n. But if you can see here it is s raised to n plus 1. पण मला तर s raised to n हवाय. मग काय करूया? सगळ्या n ला n minus 1 ने रिप्लेस करूया. Replace all n by n minus 1. So n minus 1 plus 1 निघून जाईल आणि n राहील फक्त. Right? So what will be this formula? Laplace of t raised to n minus 1. N is now n minus 1. N minus 1 factorial upon s raised to n minus 1 plus 1. What is that? N. If n is positive integer. And it is gamma.
N.
N is now n minus 1. So n minus 1 plus 1. N upon s raised to n minus 1 plus 1 s raised to n in general. त्याच फॉर्म्युलाला मी फक्त अपॉन एस रेस टू एन येईल असं केलंय म्हणजे मी एन ला एन मायनस 1 केला. दॅट्स इट सगळीकडे. नाव दिस लॅपलास इनव्हर्स 1 upon s raised to n, it will be Laplace inverse. This is n minus 1 factorial constant will go down here. So it is t raised to n minus 1 upon n minus 1 factorial if n is positive integer. Getting this formula?
Yes, ma'am.
Right? Laplace inverse we are writing here. 1 upon s raised to n. हा फक्त इकडे शिफ्ट झाला. इकडे हा मल्टिप्लाय इकडे जाऊन डिवाइड होईल. Next formula, or it is Laplace inverse of this gamma n.
n minus 1
Right? Upon
gamma
I
n.
divide with gamma n, but it is in general. So yes, this is next formula and last formula in inverse Laplace transform. So can we combine it together now? Chalo. So I'll give you at one place. You should remember them. Laplace inverse 1 upon s. It is 1. Laplace inverse of 1 upon s square काय असेल? नंतर सांगा. स्टँडर्ड लिहूयात आधी. Laplace inverse of 1 upon s minus a e raised to at. इथे जर निगेटिव्ह असेल तर तो e च्या पॉवर मध्ये प्लस होईल. थर्ड, Laplace inverse 1 upon s plus a e raised to minus at. Laplace inverse of 1 upon s square plus a square 1 upon a sin at. Next, Laplace inverse s upon s square plus a square. What is that?
Cos 80.
Very good. Next is Laplace inverse 1 upon s square minus a square. Is 1 upon a
Sin
hyperbolic at. Very good. Next is Laplace inverse s upon s square minus a square. Cos
Cos hyperbolic
at. And last, Laplace inverse of 1 upon s raised to n. It is
t raised to n minus.
t raised to n minus 1 upon n minus 1 factorial if n is positive integer, and it is
T raised to n minus
n
1.
minus 1 upon gamma n in general.
general.
Right. So can you now tell me Laplace inverse of 1 upon s square, n is 2, which is a positive integer.
T raised to 4 upon 20.
T raised to 2 minus 1. T raised to 1 upon 2 minus 1. 1 factorial is 1. So have you seen this in Laplace of t is 1 by s square? Just opposite of that. Laplace of inverse of 1 upon s square is t. Can be used as a formula also. If you can't, you have this. Can have. Yes, so these are the formula you should remember while coming to the next lecture. They are now in force. Like पहिले जसे लॅपलासच होतं, आता हे सगळे आपल्याला पुढे सॉल्व करायला लागतील. म्हणजे एक दोन क्वेश्चन घेऊयात आपण. राईट द क्वेश्चन. Find Laplace inverse of 1 upon s raised to 5. 1 upon s raised to n. T
T raised to 4
n minus 1 upon n minus 1 factorial, correct?
Yep.
T raised to 4 upon 4 factorial, that is t raised to 4 upon 24. Answer. आता समजते तुम्हाला काय येणार आहे, एस मध्ये येणार आहे आणि ते तुम्हाला बॅक टू टी टाकायचे. सेकंड क्वेश्चन बघा, एस अपॉन एस स्क्वेअर मायनस 36. वरती एस आहे म्हणजे हा कॉस असणार आहे किंवा कॉस हायपरबोलिक असणार आहे, हे ठरणार आहे कुठून, त्या खालच्या साइन वरनं. इथे निगेटिव्ह असेल तर हायपरबोलिक, पॉझिटिव्ह असेल तर कॉस. So this is s square minus 6 square. S upon s square minus a square. What is that?
Yes, ma'am. Cos
Cos
hyperbolic.
hyperbolic 6t. Next. Laplace inverse of 1 upon s plus 4.
E raised to minus 4t.
E raised to minus 4t. आता हे फॉर्म्युलावरच लिहिते मी सगळं. 1 upon s plus 4. A is 4. So e raised to minus 4t. Next. Laplace inverse of 1 upon s minus 2.
E raised to 2t.
E raised to 2t. Everyone is getting just on the formula,
Yes, ma'am.
right? So Laplace inverse of 1 upon s square plus 16. That is Laplace inverse 1 upon s square plus 4 square. Which formula? 1 upon s square plus a square. This formula. What is that? 1 upon a sine 80. So what is that?
1 upon 4 sine 4t.
Correct. 1 upon 4 sine 4t. Right. Next. Laplace inverse s upon s square plus 81.
Cos 9t.
Very good. It is 9 square. So it is s upon means cos and a is 9, so it is cos 90. And last thing, Laplace inverse 1 upon s raised to 5 by 2. 5 by 2 is in general. That is t raised to n minus 1. 5 by 2 minus 1. Upon what? General wala formula. Upon gamma n. So gamma 5 by 2. Gamma 5 by 2. So what is t? 5 by 2 minus 1?
3 by
3 by 2. Upon gamma this. What is the answer? Start with minus 1. 3 by 2.
2.
Again minus 1. 1 by 2. Into root pi. So it is t raised to 3 by 2 upon 3 root pi by 4, and that by 4 will go up. So yes, that is the answer. So do you get the idea what is exactly the Laplace inverse?
root.
Yes, ma'am.
जे आपण लॅपलास मध्ये
Yes, ma'am.
केलंय, करेक्ट, जे लॅपलास मध्ये झालंय ते एक्झॅक्टली अपोजिट करून वापस टी मध्ये टाकणं, याला म्हणायचंय इनव्हर्स लॅपलास. आणि सेम फॉर्म्युले सेमच आहेत ना, तर काही चेंज आहे? ज्याला लक्षात नाही राहणार आहे ते मॉडिफाय करून पण करू शकता जर लॅपलास लक्षात असतील तर, राईट? So it's exactly similar to Laplace. Just remember them. I am taking attendance. Please wait. If you have any doubt in between, go ahead and ask. Oh, I'm done. Do you have any question, any doubt, anything? If no, we can stop.